Good morning, everyone. My name is Shubham chauhan. I'm from second year E&TC from International Institute of Information Technology, Pune. In this presentation, I have to present my 4 questions. The outline of this presentation contains from question number 1, the execution part, question number 2, explanation of a concept, question number 3, again, it's an execution of a problem statement that has been provided. And question number 4 is the explanation of concept of any concept of my choice. So question number one. In question number one, I have to write a program that prints the integer from 501 to 600. But for multiples of 3, I have to print my name, and for the multiples of 5, I have to print my surname. And for the numbers which are multiples of both 3 and 5, I have to print both my name and then surname. Let's go to Jupyter Notebook for that. Here, I have written the program for the question. The first part is I have made a function variable which takes input of my name, then a variable your surname which takes input of my surname, and then I have added both of them for creating a third variable for both my name and surname. Here, as we can see in the function, we have used a for loop. So for numbers in range 501 to 601, we have included written 601 because this range function doesn't include the last number. So we always have to add a number greater than what we want. So for if a number is both a multiple of 3 and 5, then we have to print my name and my surname. We have used the AND operator for that. Else, if it's divisible by 3, we have to print my name. If it's divisible by 5, I have to print my surname. Else, just simply print the number. Let's run this. Name. Here you can see 501, which is multiple of 3, is written shubham. And then this way every third number is my name. Then 505 here, it's written chauhan, my surname. Every fifth number is written that way. And then every 15th number contains both my name and my full name, my name and surname. Now for the next question, let's go back to the presentation. Okay, the second question is, what is data wrangling or data cleansing? So data wrangling is basically the essence of data analysis. Here what we have written is the data wrangling is transformation of data from one type or another to make appropriate for application or algorithm. The data that we get in there, first of all, in many formats such as JSON file, CSV file, or sometimes a pickle file, which is mostly used in machine learning formats. Which they are for the data which cannot be classified in every form. So, and data analytics includes these three things: data aggregation, data visualization, training statistical model for predictions. Firstly, we have to aggregate the data. Sometimes when we represent the data mostly using pandas, we might need to add some new columns which contain the properties of some other two columns, and we might also need to add data of different types together to find out properly find out what we're looking for. This is an example of data aggregation. Just like this image we can see here, it has option of 1 day, 1 week, 1 month, 3 month, 1 year, and 5 year. These all can have a daily data, and then when we are looking for 1 week, when we are looking for 1 week data, then it aggregates the data of all 7 days and then presents it. Now, similar and the graph that we can look, that's the example of data visualization, and this is statistical model for predictions. The data that we collected, the stock market data that we can see here, that can be used to predict what might be the prices of in the upcoming days or upcoming days based on the past behavior. Data cleaning is one of the most important topics in data analysis, data science. The data we get, it almost always has missing values, outliers, non-standard values, and data quality. The data we get, the data scientists, they're almost always busy cleaning and transforming the data sets. According to some surveys, almost as much as 80% of the time of data scientists is used to clear and clean the data. Missing values are available in different format. Mostly when data scientists come across some missing values, they rename them or they transform them into NaN values, Na or none, depending on which language they are using. In R, the standard procedure is to use NaN. In Python, we have options for using NaN, Na or none. R is also uses any. Uh, uh, Having a clean data set is the most important. We can say is the most important requirement for creating any visualization or interpretation that we want. Now, third question. My third question is that I have to import hotelsbooking.csv. Then after importing this CSV file into pandas data frame, I have to remove index column and replace all junk values with NaN values. Thankfully, in pandas has a function for doing all of this. Now let's check data types of each column in the data frame and convert data types of any two columns. Let's go to the Jupyter notebook for that. First, we have to import the necessary module. We are only using pandas, so we'll only import pandas. Here in this function, you can see this data. R represents reading of the data, and this is the address of data, the address of where I stored the file. hp.data I have simply imported it into a file hp.data, and in PD here PD represents panda, and the function is read.csv, read underscore csv, which reads CSV files. Here I have told them that the NA values in this data set are represented by dot. Now after importing the data set, if I have to import, I have to present it in a data frame. So hp underscore df, this is a standard procedure to name the data set the data that, as df. This is following this standard procedure is important, since when other data scientists look into your data, it's easier for them to understand what you have written and what you are trying to show. So pd.data frame hp data. Let's run this. So importing all of the data at once, it will cause server error, and this notebook and kernel will shut down. So usually we use functions such as dot head function to represent the top 5 lines. Here the top 5 lines are represented. Alternatively, we can also use slicing them. Slicing will be hp underscore data df underscore, let's say we need the first 10 rows here. So 0 to 9, here are our first 10 rows. Pandas is useful. This is one very important properties of Panda, that it helps us slice and slice, aggregate, separate data into all formats we type. We can see here these are all junk values which have been converted into NaN. Pandas converts all the junk values that we have provided. NA values are represented by dot, and so it will convert them into NaN values. If you want to check the values, we can use the isNA function of pandas. Now, for moving to the second part of the question, the second part of our question was hp underscore df dot d types. This helps us use to know the types of data types, the data types that are present in our CSV file or the data whatever you're using. See, okay. So these are all the columns that we are using, and that they are present in my data frame, and on the right side are all the D types. Object data types, they usually represent things such as strings or any other data types which are not integers or floats. In 64, this is a standard format. The numbers which are represented, the numbers are represented by the int data type, and the decimals, the numbers containing decimal are represented float 64 data types. Now, second part of question was changing our data types. The first, we need to create a dictionary which contains the key. When here key is the name of the column that we want to whose data type we want to change, and the value is the data type into which we want to change. So yeah, lead time, here we can see lead time was in 64, and the second part was adults. The number of adults entering into the hotel, here it was also in 64. So we are going to change them into string. You can see first was object and lead time. Lead time was earlier in 64, now it's object. Adults was earlier in 64, now it's object. Moving on to fourth question. The fourth question is that I have to explain a topic of my choice, so I've chosen pandas. Panda is a very important library. It's actually one of the libraries which transform Python into such huge what we can say uh, users who started using Python for their data science applications. This was one of the most basic or most starting models available. Pandas was derived from the word panel data. You can see here pan from panel and data and da from data. And is also based on the phrase Python data analysis itself. Python provides high-level data structures and functions. Python, as we have already seen, Python's function when we are seeing data structures. So pandas are essentially used from essentially derived from the usability of the R language, which provides a lot of mathematical and visual functions for representing data sets such as data frames. And it also provides the relational database facilities. Blends the high performance and array computing ideas of NumPy, which again was imported from R, and then flexible data manipulation capabilities of spreadsheets and relational databases, which is SQL. Let's go to our Jupyter notebook and let's use it. Pandas. NumPy was useful for handling data as it efficiently applies function to whole data sets. In generally Python, we have lists, but lists are slow, and NumPy is something which optimizes the operating time of applying functions to all of them, and we can also apply a mathematical function to the whole list individually, which is not possible in strings. However, it is difficult to keep track of related data that might be stored in different arrays. Like NumPy is also is a type of array, so the data type of entire array is the same. Entire NumPy array is same. That's where pandas comes in. Pandas provides a very useful application of data frame. Uh, let's use it. For first we have to create a data set. So we have to use type of stats in NumPy. Let's create a function which creates 10 football team according to the way we want. Here we have in the list we have collected the name of some of the legendary footballers. Ronaldinho, Pele, Messi, Zidane, etc. Now we want to create shoe size and jersey numbers for them. So we have to generate football team length of players. Let's use the data frame. Here we created like created, let's see, Ronaldinho, Pele to Robert Doranoni. All we have created a list of shoe size and jersey size. This is a pandas data frame, and this is the index. We have indexed it. We can also use the numbers to index it. If you don't use these names, then pandas automatically provides numbers. We can see here. It is all automatically provided numbers as index values. We can hide it by using style method. Now we can also make pandas data frame using zip, such as we might know that when we are creating a dictionary, we might create two lists and then zip them together. This is essentially what we have done. We have created shoes and jerseys dictionary, zipped them into a data frame, and provided the column name, shoe size, and jersey, and provided that index is the name of players. Let's run it. See, it provides the same data frame as above. Data frame has similarities to both dict and numpy array. For example, we can retrieve a column from data frame by using its name, just like we would retrieve an item from dict using its key. Uh, let's print. Here we use the index. The slicing method was we use the name of the column to print out the shoe size. We can individually print out the entire columns with the index. It also presents the data type of data type. We are here using decimals, so this is the float 64 data type. And just like NumPy, we can also apply mathematical functions to log to the entire column. and we are using mean. The mean of the shoe size is 9.63, and the mean of entire jersey sizes is 96.92. Now let's see how to retrieve, add, or remove data from a data frame. The What about retrieving a row? So the most flexible syntax that we have seen is that we can use uh, lock method. We can always try to create new ways to import rows, but these are the most standard functions by pandas, and these will always guarantee you the fastest result. Let's print this. It prints it prints our rows and the accommodating column size that we want. Earlier in this method, we already only printed Ronaldo, the row of Ronaldo, so it presented us with both shoe size and jersey size. But in this question, we have created Ronaldo and George Best. We have imported the rows of Ronaldo and George Best, but we only want their shoe size. We can also select position-based slices of data, and just like we use a number. And here, and like earlier, here I've shown you that we can use the number by indexing. Since we are using index, so index can be used to represent data. Index is always used to when we want a row, we are always going to retrieve it using the index. But we can use the position based, like we can import from Ronaldo to George West. iloc basically I represent for integer, so we can use the location with the numbers, index value numbers also. And just like we used the semicolon to represent from Ronaldo to George Best, we can also do that with numbers. Now, see the top of the data frame earlier, like we can use head. These always represent the top five numbers, and when you use tail, it always represents the bottom five numbers. Now let's add a new column. We have already presented. Now at the now at let's add what we can do. We are like randomly allotting the data, not positions. So for that, we are creating a new column. See here, df.head. We provided position for everyone. Well, this is wrong goaltender. He was a attacking midfielder. Let's add a new row. So the new row is we have created player named Dylan. So Dylan has a jersey size of 91, shoe size of 9, and his position is midfield. Now let's try to add this row. See, so we have presented df.log Dylan. To delete that data, we can always use. Let's see this in the data frame. Here we have created Dylan 9 midfield, but now let's drop the data frame. Df drop Dylan. Now it dropped Dylan, but let's see an interesting thing. We will again import the data from df. Here you can see that it is still remaining showing. We can remove them using these two functions, df.drop and df.drop this in place equals to true. But one thing is, when you're using df.drop, it returns a copy of the data frame that we are using. So in order to make the change permanent, we have to assign that copy to the original value. Let's run this. See, here so, and here Dylan is removed. Another way is that when changing this when deleting dropping this, we can make this change permanent by using in place true, right? This in place true, it makes that it doesn't make a copy, it changes the original data frame. Here we try to drop the drop position column. It changed the original data frame and printed this.